Okay guys, buckle in your seatbelts because this is going to be a long video, but this is everything you need to know for your test. So if you watch this video, you can basically learn everything we've done all semester and a little bit of what we learned last semester. Now, one of the key points that I want to go over are a few main things. So one, we have 6 steps on our ratio method, okay, of cross multiplying. Okay, and I want to just write down these 6 steps just like we did in class. So if you didn't write them down or you weren't in class, you have them. So remember, our first step is we always write down the given, okay, whatever's given to us in the problem. The second thing is we set our problem equal to x, find, okay, and your find are the units they're looking for. So oftentimes in the problem it'll say how many moles of this or how many grams of this compound, right? And whatever that is, that's what you're trying to find. That's the unit they want you to convert to. The third thing we do is we bring it on down, and we'll explain what that means in a little bit. The fourth step is we put our number next to our unit. Okay, now depending on the unit, our number will change. So for example, anytime we see the word mole, we write 1 because our conversion factors are always equal to 1 mole. If we see grams, which is the same thing, is used for mass, we would write our molar mass, which is calculated from the periodic table. Okay, and if we have any of these next 4 words, so if we see the words particles, which remember is just a sciencey word for things, formula units, which is used for ionic compounds, molecules, which is used for covalent compounds, or atoms, which is used for singular elements, all 4 of these words get Avogadro's number, which is 6.02 times 10 to 23. Now, one key thing about that is remember, this number must be memorized. Memorized, okay? I can't say that enough. I am not giving you this problem on your, or this this number on your test. You have got to remember it, okay? Now, step number 5 is we, if the left side and right side have different compounds, then I'm going to abbreviate compounds as CMPDS. Then what we're going to do is we multiply by our coefficient. Okay, and then step number 6, we cross multiply and solve. Now, it looks like a lot, but it is the same 6 steps that we have been doing over and over again since January. Now, a few key vocabulary words that I want you to pay attention to is, one, you want to know about mole ratios. Okay, mole ratio is if I have a balanced chemical equation, for example, 2H2 plus O2 produces 2 moles of water, and I want the mole ratio of hydrogen to oxygen, I would say that I have 2 moles of hydrogen over 1 mole of oxygen. And now where I got these numbers comes from my coefficient here. Now if there's not a number like in front of number 1 or in front of oxygen, then it's just a 1. Remember, chemists are really lazy. We don't write our 1s in our chemical equation. Okay, but that's how you would write the mole ratio. And then another one is limiting reactant. Okay, now your limiting reactant limits the amount of product you can make. We did this when we did our s'mores lab. Remember that our chocolate was what ran out first. We couldn't make more than 5 s'mores because we didn't have enough chocolate. So it usually runs out. Not all the time, but most of the time that's a key indicator that that's what's running out. Okay? Our excess reactants are left over. These are the things, these are the ingredients, our reactants that we had more than enough. Okay, so we have plenty. All right. Oh, one other thing is remember, you needed to memorize your percent yield formula. So percent yield is equal to your actual calculated amount divided by your calculated times 100. So this you get in the lab, and this value you get from your math. Okay, this is usually done in your like pre-lab of an experiment or something like that, but we will do a sample problem where we work with that in just a moment. Okay, but let's get down to our actual questions. Now, in order to do these questions, you need to have two very, very important items in front of you. You need a periodic table and you need a calculator. Now, if you're at home watching this and you don't have a periodic table, you can pull one up on your phone. There are lots of apps for them, and all your phones should have a calculator. So you should still be able to do this at home. Okay, so in number 1, it says, in the following reaction, and then they give us our equation, how many moles of oxygen would be required to react with 16 moles of hydrogen? Now, the key thing here is they give us two important pieces of information. They tell us what's given, right? They give us 16 moles of hydrogen, and they tell us that they want to find moles of oxygen. That's what they're looking for. So what we're going to do is we're going to follow these steps exactly as we wrote them. So the first step is given. Okay, so they give us 16 moles of hydrogen. Now hydrogen in our problem is H2 because it's diatomic, so I'm going to write that, H2. And if we look at our second step, we set it equal to X, whatever we're trying to find. So equal to X, we're trying to find moles of oxygen, which is also O2, and we get that from our equation. All right, so that was step number 2. Next, step 3, bring it down. Now this means we put our fraction and we bring the units that we have on top down to the bottom. So because I wrote moles of H2 on the top, I'm going to write moles of H2 on the bottom. Because I wrote moles of O2 on the top, I'm going to write moles of O2 on the bottom. Step number 4, as we can see, is we put our number next to our unit. So in both of these cases, I see the word mole. And every time we see mole, we write the number 1 beside it. So now we look at step 5. If the left side and right side have different compounds, then multiply by our coefficient. Well, if I look at this, I have hydrogen on the left side and oxygen on the right side, which are two different compounds. So I look for my coefficient in my problem, which in front of the hydrogen is a 2, and in front of my oxygen, I don't have anything. So that means I'm going to multiply by 1. So hydrogen gets multiplied by the 2, and oxygen gets multiplied by 1. And step 6 is lastly to just cross multiply and solve. So what I'm going to do first is I'm just going to simplify my denominator. Okay, so I'm going to keep my 16 moles of hydrogen over 2 times 1 is going to give me 2 moles of hydrogen, and it's equal to x moles of oxygen over 1 times 1 is just 1 mole of oxygen. And when I cross multiply, it's important to note that I'm multiplying the entire bottom by this top left corner, and that we only have to cross multiply in that direction in order to get x by itself. So 1 times 16 is going to give us 16 moles of H2 moles of O2 divided by 2 moles of H2 equal to the other side of our equation, which is x moles of O2. So when we look at this, we see what can cancel out. I have moles on the top and on the bottom, hydrogen on the top and bottom. So that's going to leave me with just moles of O2, and then 16 divided by 2 will give me 8. And I have reached my final answer because my moles of oxygen here match my units that I was looking for. So I know I've reached the correct answer. Let's move on to problem number 2. So problem number 2 says, in the following reaction, silver chloride plus sodium nitrate produce silver nitrate and sodium chloride. How many moles of silver chloride are needed to react with 4.0 grams of sodium nitrate? Now remember, our 6 steps every single time. The first step is our given. So our given is right here. It's my 4.0 grams of NaNO3. So I'm going to write 4.0 grams of NaNO3. Now, on your free response questions on your test, when you have to show all your work, writing down the given will give you at least 1 point. So partial credit is your friend. Show all of your steps. Step number 2 is to find our given. Well, here we see how many moles of silver chloride. So what we do is we set it equal to x moles of silver chloride. Step number 3 is we put it into our ratio and we bring it down. So because I have grams of NaNO3 at the top, I put grams of sodium nitrate at the bottom. And because I have moles of silver chloride at the top, I bring moles of silver chloride to the bottom. Step number 4 is we write our number beside our unit. So let's go back and review. So if it says mole, we write a 1. So I see a mole here, so I'm going to write sorry about that. I'm going to write a 1. And if we look, grams is our mass, which means I have to calculate my molar mass, and we calculate it by using our periodic table. Now, what I've done is I've already listed out the mass of the elements we're going to need because I don't have a periodic table with me, and I know that's shameful as a chemistry teacher, but I wrote it down anyway. So to calculate our molar mass, we're going to have Na, we have N, and we have O. And if we look, our subscripts for these are 1, 1, and 3. We multiply by the mass that we got from our periodic table. Sodium is 22.99. Nitrogen is 14.01. Oxygen is 16.0. We get 22.99, 14.01, and 3 times 16, when it's done in our calculator, will give us 48 grams. And then I add them all together. So 22.99 plus 14.01 plus 48 is equal to 85 grams per mole. So I can plug that number in right here on the left side of my equation, and I have completed step number 4. Now remember, step number 5 is to multiply if I have two different compounds. So on the left side, I have sodium nitrate, and on the right side, I have silver chloride. So that means I'm going to multiply by my coefficient. Now, my coefficient for sodium nitrate, well, there isn't one, which means it's a 1. And in front of silver chloride, there is not one, so it's a 1. So when I multiply by 1, that doesn't really change my answer much. So when we cross multiply, which is our last step, and I multiply all of this by all of that, okay, we're going to get 1 times 1 is, well, 1, times 4.0 is going to keep it at 4.0 grams of sodium nitrate, moles of silver chloride, over 85 grams of sodium nitrate is equal to X moles of silver chloride. Now, when I do this, I see one thing cancels out. I got grams sodium nitrate canceling out with grams sodium nitrate here. And when in my calculator, I say 4.0 divided by 85, I get 0.047 moles of silver chloride as my final answer. All right, let's look at problem number 3. Problem number 3 says how many grams of aluminum phosphate are produced from 12 moles of aluminum nitrate in the following equation. So again, our same 6 steps. The very first thing we do is we write what's given to us. So they give us 12 moles of aluminum nitrate. So I need to write 12 moles of aluminum nitrate. So I'm going to write my 12 moles. Now, aluminum nitrate probably has aluminum and something with nitrogen in it, right? You should be able to look at the back of your periodic table and see that nitrogen is NO3. But you at least, or nitrate is NO3. You should at least be able to do that from last semester. But we can also see that this one right here is the only one that has aluminum and nitrogen in it. So they kind of help us out there by providing this symbol in our balanced chemical equation. So I'm just going to copy it down. Now step number 2 is we set it equal to X and whatever they're trying to find. And currently, they are trying to find how many grams of aluminum phosphate there are. Now, aluminum phosphate sounds like it probably has aluminum and phosphorus in it, which would be this one right here. So I'm going to set equal to X grams of aluminum phosphate. Step number 3 is we bring it on down. So I'm going to underline this. What I have on the top, I put on the bottom. So I have moles of aluminum nitrate on the bottom. And I have grams of aluminum phosphate on the bottom. Now, step 4 is we write whatever number we have by our unit. Now, because I have moles, I'm going to write the number 1 here. And because I have grams, that tells me I'm going to need to calculate molar mass again. So I have aluminum, phosphorus, and oxygen. I have 1 of these, and I have 4 oxygens. So I need to multiply them by their mass on the periodic table. Aluminum is 26.98, phosphorus is 30.97, and oxygen is 16.00. So 1 times 26.98 is 26.98. 1 times 30.97 is 30.97. And 4 times 16 is equal to 64 grams. I add them all together and I will get 121.95 grams per mole. So I'm going to write that number right here, 121.95 grams. So step number 5 is if there are two different compounds, we multiply by our coefficient. Now, on the left side, I have aluminum nitrate, and on the right side, I have aluminum phosphate. They've changed. Two different compounds, so I multiply by my coefficient. Now, the coefficient that is in front of aluminum nitrate is a 1 because there's nothing there. And in front of aluminum phosphate, again, there's nothing there. So, that's multiplying by 1 on both sides, which makes the problem a little bit easier for us. So step 6 is we cross multiply and solve. So I'm going to cross multiply all of this. So 1 times 121.95 just stays the same. So, and then 121.95 times 12 is going to give me 1,463.40 moles of aluminum nitrate, grams of aluminum phosphate over 1 mole of aluminum nitrate equal to X grams of aluminum phosphate. Now, to see what cancels out, I see that moles cancel out with moles, aluminum nitrate cancels out with aluminum nitrate. So, and 1,463.40 divided by 1, it's just going to be 1,463.40 grams of aluminum phosphate. And we have a job well done for ourselves. Let's move on to problem number 4. Problem number 4 says how many grams of water are produced from 52 grams of C3H8 in the above equation. So again, we write down what's given to us first, and they give us 52 grams of C3H8. So I'm going to write that down, 52 grams of C3H8. And we set it equal to X, whatever we're trying to find. And in this case, we're trying to find the grams of water. So I'm going to write grams of H2O. So step number 3 is we list it in a ratio, and we bring our units down. So grams C3H8, grams H2O. So both of them have grams, which means I need to calculate two different molar masses. So the first one I'm going to calculate is C3H8. So I have carbon and hydrogen. I have 3 carbons and 8 hydrogens. I multiply them by the mass on the periodic table, which is 12.01 and 1.01. So when I do that, I get 3 times 12.01 is 36.03, and 8 times 1.01 is 8.08. So when I add them together, I get 44.11 grams per mole. So I'm going to put my 44.11 grams right there. And now I'm also going to calculate the molar mass of water. I have H and I have O. I have 2 hydrogens and 1 oxygen. Multiply them by their mass on the periodic table. And when I add them together, I'm going to get 18.02 grams per mole. And I will write that on the right side, right beside my grams, because grams always tells me that I go to the periodic table to find my mass. Okay, so step number 5 is we multiply it by our coefficient if there are two different compounds. In this case, I have C3H8 on the left and H2O on the right, two totally different compounds, so I'm going to multiply by my coefficient. Now my coefficient here in front of C3H8 is a 1, and in front of water is a 4. So that means I'm going to multiply this one by 1 and water by 4. okay? Which is really going to cause me to need to simplify this problem first. So 52 grams of C3H8 divided by 1 times 44.11 is going to say 44.11 grams of C3H8 equal to x grams, x grams of H2O divided by 4 times 18.02 is equal to 72.08 grams of H2O. I'm going to cross multiply this right here, exactly like we've been doing. So 72.08 times 52 is going to give me 3,748.16 grams of C3H8 grams of H2O is equal to x grams of H2O. And I'm going to divide it by my 44. Going to divide it by my 44.11 grams of C3H8. And one thing that we need to take note is that my grams of C3H8 is going to cancel out with grams of C3H8. And that means when I divide 3,748 by 44.11, my calculator will give me 84.97 grams of H2O. For problem number 5, let's just mosey on down to it. Okay. Problem number 5 says how many grams of FeCl2 or iron chloride are made from 8.67 grams of copper chloride. Now again, we start off with what's given to us. They give us 8.67 grams of copper chloride. So I'm going to start by writing that down. 8.67 grams copper chloride. And we set it equal to X, whatever they're trying to find. And they're trying to find the grams of iron chloride. All right, X grams of FeCl2. Step 3 is to bring it on down. So we bring our grams and copper chloride down from the top. We bring our grams of iron chloride down from the top. Step number 4 requires that we put our number by our unit. And so that means we're going to need to calculate molar mass because I see grams on the bottom. So for copper chloride, I have Cu and I have Cl. Okay, copper has 1 times 63.55, and chlorine is 2 times 35.45. And when I do this, I get 63.55, and 2 times 35.45 will give us 70.9. And when I add them together, I get 134.45 grams per mole. Okay. Now this number is going to go right beside my copper chloride in my problem. And I'm also going to calculate iron chloride, FeCl2. So I have 1 and 2. Iron is 55.85. Chlorine is 35.45. This will give me 55.85, 35.45, and when I add them together, I get 91.3 grams per mole. So I'm going to put that right here. Now, because I have two different compounds, I'm going to multiply by my coefficient. which my coefficient in my problem for iron chloride is going to be a 1. And for copper chloride, it's also going to be 1. So nothing really changed there. So if we multiply by 1, again, that's not really going to change my overall answer. So when I cross multiply this whole bottom piece times this top piece, okay, I have 91.3 times 8.67, and I get 791.57 grams CuCl2, grams of FeCl2 over 134.45 grams of copper chloride. And this is, of course, all equal to grams of iron chloride. That's what we're converting to. So I see that my grams of copper chloride cancel out with grams of copper chloride. And 791.57 divided by 134.45 is going to give us 5.89 grams of iron chloride as our final answer. Hopefully you're getting the hang of this by now, but you still have more practice problems, so we're going to keep going just in case you still haven't mastered it. But you can always rewind and listen again if you think you missed something. So question number 6 says, how many moles of hydrogen are needed to completely react with 2 moles of nitrogen in the following balanced equation? So what we're going to do is start off with what's given to us. They give us 2 moles of nitrogen, and they want to know how many moles of hydrogen there are. So I'm going to take my 2 moles of nitrogen, which is going to be N2, and set it equal to my X moles of hydrogen. And I'm reminded that they are diatomic, as in N2 and H2, by my balanced chemical equation here. I'm going to bring it on down. So moles of NO2 will come down to the bottom of my fraction, and moles of H2 will come down to the bottom of my ratio. Because remember, a ratio and a fraction are exactly the same thing. So we got to put our number by our unit. Both of them say moles, which means I only write the number 1 there. Because they are 2 different compounds, I need to do step number 5, which means I need to multiply by my coefficient from my balanced chemical equation, which, if I look at this, shows me that nitrogen does not have 1, but hydrogen does have a coefficient. So nitrogen will just be multiplied by 1, and hydrogen will be multiplied by 3. So this is going to be a very simple question. We're going to cross multiply like we've been doing. 3 times 1 is just going to be 3. So then 3 times 2 gives me 6 moles of nitrogen, moles of hydrogen, over 1 mole of nitrogen, because 1 times 1 is just 1, equal to X moles of hydrogen. And that 6 divided by 1 is 6. And my moles of nitrogen here cancel out with moles of nitrogen here. So I have 6 moles of H2 is equal to my X moles of H2, which is perfect for what we need because my units match on both the left and the right side, which is always a good sign. Now, let's look at question number 7, because question number 7, ooh, is it tricky because it's got this key word in it, the one you all hate. It says, ooh, we need to balance it. We can't do anything without a balanced chemical equation. So first thing we're going to do is we are going to list out the elements we have. We have carbon, hydrogen, and oxygen. Now, let's keep track of our total number. Remember, because we don't have coefficients here, they're just blanks, it's kind of like there's imaginary ones there. Okay, so if we think about it, 1 times this subscript 3 is 3 hydrogens, 1 times 8 is 8, and 1 times 2 is 2. Now on the right side of my arrow, which remember the left side is called reactants, and the right side is called product. Okay, if we go to our product side, I have 1 carbon, I have 2 hydrogens, and then oxygens get a little tricky. I have 2 oxygens here, but I also have this 1 over here in water, so that's 2 plus 1 is going to give me 3 total. And you're like, oh man, like oxygens, they're a pain, and they are. But what I recommend doing is balancing those last. Things tend to work out if you balance carbon and hydrogen first. So in order to balance out carbon, we're going to need to start on the side that has the smallest amount. So we see from our numbers that the right side only has 1. So in order to change my answer, I need to multiply by a coefficient, by a number. If I want it to be 3 and I have a subscript 1, that means 3 times 1 is equal to 3. And it will change my answer. But make note that it's the 3 is being multiplied by my subscript. In this case, it's a subscript I wrote in because normally chemists are lazy. Not being multiplied by this 1 down here that I wrote next to my C. That's just where we're going to keep track of our answers. So that also gets multiplied by my oxygen. So 3 times these 2 oxygens are going to give me 6 oxygens, plus this one over here gives me a total of 7 oxygens. So be careful there. You don't want to get tripped up. And so now my carbons are balanced. Well, let's balance hydrogen. Hydrogen has 8 on the left and 2 on the right. Because 2 is smaller, I'm going to start on that side, and I say, okay, I want to make 2 into an 8. And the only way to do that is to multiply by 4. So if I put a 4 right here in front of water, I can say 4 times 2 hydrogens is 8. And it's also going to be multiplied by my oxygens. So 4 times 1 gives me 4 on that side, and 3 times 2 gives me 6 on that side. So total, they make 10. And that actually makes solving for oxygen so much easier because I did carbon and hydrogen first. Because now, in order to make the left side equal the right side, I only need to put a 5 here. Because 5 times 2 gives me 10, and I'm completely balanced. Now, the key thing here is if we look at A, it says if you start with 14.8 grams of C3H8 and 3.44 grams of oxygen, determine the limiting reagent. Now, that is a huge thing here. They want to know the limiting reagent. And what that means, we're just going to come over here for a second. What that means is that your answer is a reactant. Okay? Meaning your answer is either going to be C3H8 or O2. You have to pick one. Which of those ingredients, which of those reactants is limiting the amount of product you can make? So in order to do that, you have to convert both of them into a single reactant, or a single product, excuse me. So what we're going to do is we're going to say, okay, if I have C3H8 and I have oxygen, I need to convert it to just one of my products. Let's convert it to water, okay, just for funsies. We could have easily picked carbon dioxide, this other one, but I like water better, so let's do that. So the given of our problem is we actually have 2, which is why limiting reactants can be so tricky. So I have 2 of these. So if we look, I have 44 grams of oxygen and 14.8 grams of C3H8. So what I'm going to do is I'm going to write both of them down. 44 grams of oxygen and 14.8 grams of C3H8. And we're going to convert them all to grams of water. Actually, let's just convert it to moles. It really doesn't matter which unit we convert it to because it doesn't ask us specifically. So if I convert it to X moles of water, okay, I'm going to convert both of these to X moles of water. We just need to be able to turn them all into the same thing so we can see which one is smaller and which one is bigger. So let's do step number 3. Bring it on down. So we have grams of O2, moles of H2O. Always by moles, I write a 1. And grams is my molar mass. So I have oxygen, I have 2 of them, times my 16.00 grams, equal to 32.00 grams per mole. So I'm going to put my 32.00 grams, and I'm going to multiply by my balanced chemical equation, which in front of oxygen, I had a 5, and in front of water, I have a 4. And so now I will cross multiply and solve. So I'm going to multiply everything in here by everything in that top corner. So 4 times 1 is just 4. But 4 times 44 is going to give me 176 grams of O2 and moles of H2O over 5 times 32, which is 160 grams of O2. Now my grams of O2 cancel out with grams of O2. Oops, forgot to write equal to X moles of H2O. So then 176 divided by 160 will give us 1.1 moles of H2O. Now we're not done because we didn't convert our bottom one, or our C3H8. So let's go back to that. We create a fraction, okay? We bring it on down. We got grams of C3H8 and moles of H2O. Moles always has a 1 written beside it. If I'm not mistaken, we already calculated the molar mass of C3H8 in another problem. So let's see if we can't find that here. Yes, we did. In problem number 4. Problem number 4, we calculated C3H8 to be 44.11 grams per mole. Yay for not having to calculate that again, which means it's a good thing I showed my work. So I can write my 44, oops, let's switch back to our pen, our 44.11 grams right there. And because they are 2 different compounds, I'm going to multiply by their coefficient. We know that water has 4 and C3H8 has nothing, which means it's a 1. So when we cross multiply, we're going to multiply that side by this side. So 4 times 14.8 needs to be done in your calculator, and it will give you 59.2 grams of C3H8 moles of H2O over 44.11 grams of C3H8. It's all equal to my X moles of water. Now 59.2 divided by 44.11 is going to give us 1.34 moles of H2O. Now, if we look at our 2 answers, okay, so far we've got this right here, 1.1 moles of H2O and 1.340 moles. The way to tell if it's a limiting reactant is you pick the smallest. So in this case, water only produced 1.1, so that means H2O is the limiting reactant. And oxygen is going to have some left over. So, what if we start with, or continue with, problem number 8? Now, problem number 8 has 3 different parts in it. You have to balance it. You have to do a conversion problem with our cross multiplying. And you also have to calculate our percent yield. Now, let's go ahead and just dive right on in. So, in order to balance it, we need to list out our elements. So we have iodine, oxygen, and carbon. I have 2, 6, and 1. And then I have 1, 2, and 2. Now, just as a thought, okay, one way that we can change this is we have 5 here, and we have 1 here, and that's really inconvenient because this is just, they're both not adding up to a number that's going to be easy for 2, because every time I change my carbon on, or my oxygen on the right side, it's going to automatically change my carbons, which is going to mess everything up. So I'm going to give you a hint and tell you that we start with a 5 there. Now, sometimes you just got to plug in problems. Luckily, you won't have one this hard on the test, but 5 times 1 carbon is 5. And, excuse me, I'm a little sleepy while I'm making this. 5 times my 1 oxygen is 5, plus these 5 over here give me a total of 10. So in order to fix this, I put a 5 right here, and 5 times my 1 oxygen is 5, and 5 times my 2 oxygens is 10. So sometimes you just get these crazy ones that look hard and can be, but sometimes actually have a somewhat simple answer. So letter A says excess iodine 5 oxide, or I2O5, reacts with 28 grams of carbon monoxide, which is CO. Determine the mass of iodine which could be produced. So they have a given for us. We're given 28.0 grams of carbon monoxide, and they want to know the mass, which is grams, of iodine. So we've done step 1, which was write down our given, and step 2, which was put equal to X, find. In step 3, we bring it on down. So I'm going to bring down grams of CO and grams of I2. And grams tells me that I need to calculate the molar mass. So the molar mass of CO, I have 1 of each. Carbon is 12.01. Oxygen is 16.00. So when I have 12.01 plus 16.00, I'm going to have 28.02 grams per mole to write down. And the molar mass of iodine is I just have iodine, but I have 2 of them. It's times 126.90, which is much heavier than my carbon or hydrogen was. And I say 126.90 times 2 gives me 253.8 grams per mole. So I'm going to write my molar mass next to my grams of iodine, 253.8. Because carbon monoxide and iodine are 2 different compounds, I'm going to multiply by their coefficient. Okay, in my problem, carbon monoxide has a coefficient of 5, and iodine just has a coefficient of 1. So when I cross multiply, I'm going to multiply everything here times everything right here. So let's put this in our calculator. and get to work. So we have 253.8 times 28.0, and that gives me 7,106.4 grams of CO, grams of I2, over 5 times 28.02, which is 140.1 grams of CO, equal to X grams of iodine. And when I look at this, I have grams of CO, cancel out with grams of CO. So 7,106.4 divided by 140.1 is going to give us 50.72 grams of iodine. Now, the question here in part B is they want to know in the above situation, if only 0.160 moles of iodine was produced, what percentage of iodine was produced? Now, we know that this is our good old formula, percent yield, which percent yield, again, is equal to our actual divided by our calculated, or what you were expecting, times 100. Now, in part A, we're expecting to make 50.72 grams, and they say we actually produce 0.160 moles. Now, in order to do the percent calculation, they have to be in the same units. So we need to start from there. So let's convert our 0.160 moles of iodine into grams of iodine. So if I have 1 mole of iodine on the bottom here, and I bring down my grams of iodine, which my molar mass of I2, which I calculated in part A, is 253.8. Now, because iodine is the same on both sides, I do not have to multiply by a coefficient. So when I cross multiply, I'm going to have 253.8 times 0.160, which gives me 40.61 moles of iodine, grams of iodine, over 1 mole of iodine equal to X grams of iodine. So 40 divided by 1 means that my answer is 40.61 moles. Now, if I was supposed to produce 40.61 moles and I only produced 0.160, okay, that shows me something pretty significant. Okay, so let's let's plug that in. If our actual amount produced was 40.61 grams of iodine, and in our part A we calculated that we should have made 50.72 grams of I2, and multiply it by 100, that means 40.61 divided by 50.72 times 100 will give us 80%. Which, that's not so bad if you're thinking about the production of a chemical. Alright, guys, number 7 is we're on problem 9, which means we're almost finished. Problem number 9 is a empirical formula question like last test. Okay. Now, in this problem, okay, remember the way to convert empirical formula is, whoa, I don't know what just happened here on my screen, but let's go back up. Okay, our formula is percent to mass, well, our rhyme, percent to mass, just also grams, mass to mole, divide by small, multiply till whole. Okay, so we have to convert from our percents into masses or grams. And the way to do that is you just replace the percent sign with a gram. So our 18.7% becomes 18.7 grams of lithium, and our 16.3% becomes 16.3 grams of carbon, and our 65.0% oxygen becomes 65.0 grams of oxygen. So that means we have done step number 1. Now, step number 2 is grams to mole. It means we need to convert it to moles of the same thing. So we do our 6 steps. We bring our moles of lithium down, bring our grams of lithium down. Now we always write the number 1 by mole. Our mass of lithium from the periodic table is 6.94 grams. And when we cross multiply, we're going to be multiplying by 1 times 18.7, which doesn't really change anything. So really all we need to do is worry about dividing 18.7, which will go in our calculator first. So 18.7 divided by 6.94, which is going to give me 2.69 moles of lithium. And I need to do the same thing for carbon. So let's set it equal to X moles of carbon, 1 mole of carbon on the bottom, 12.01 grams of carbon here. And when I cross multiply this part, 1 times 16.3 is just that. So 16.3 divided by 12.01 is going to give us 1.36 moles of carbon. I don't really know what's going on here with my handwriting, but let's try to fix that. 1.36 moles carbon. And we're going to do the same down here for oxygen. We're going to set it equal to X moles of oxygen. We're going to divide by 1 mole of oxygen. And oxygen's molar mass, because we bring grams down, is 16.00 grams. So 65 divided by 16 is going to give us 4.06 moles of oxygen. So we have done step number 2. Step number 2 is like the hardest part, is getting that. Our third step is we divide by small. So we pick our smallest of our answers, which the smallest of my answers is 1.36 moles of carbon. So I'm going to divide everything by 1.36 moles. Divide all 3 by 1.36 moles. Now, when I do that, 2.69 divided by 1.36 gives me 1.98 moles cancel out. So 1.98 lithium atoms. Moles cancel out here. And 1.36 divided by 1.36 just gives me 1 atom of carbon. And 4.06 divided by 1.36 gives me 2.99 oxygen atoms. Okay, so we have now done step number 3. Now, my fourth step is sometimes we need it and sometimes we don't. So if we look at it as multiply to a whole, these need to be whole numbers. 1.98 is extremely close to the whole number 2. So we actually don't need to multiply because 2.99 is also extremely close to oxygen and 1 is already 1 carbon. Now instead of listing it out this way, the way I would write my final answer is Li subscript 2 CO subscript 3. And I've got a complete answer. Now remember, I could have written a 1 here, but I normally don't because chemists are real lazy. Okay, so let's move on to problem number 10. Problem number 10 says how many grams are in 7.89 times 10 to the 45 formula units of NaOH? So our first step is we write down what's given. They give us 7.89 times 10 to the 45 formula units of NaOH, and they want to know how many grams there are. So let's write down what's given. 7.89 times 10 to the 45 formula units, which I'm going to abbreviate as FU, of NaOH. And I set it equal to X grams of NaOH. And I know it's still sodium hydroxide or NaOH because they don't say that I'm changing it to something different. So I put it a ratio, and I bring what I've got down, formula units of NaOH and grams of NaOH. Now, formula units we haven't talked about yet, this whole study guide, except for at the very beginning when we were talking about step number 4, writing down our numbers. And if we look up at step number 4, which is my little computer here's not working with me, there we go. We look up here at step number 4. Alright, we can see the word formula units right here. Okay, and that means we're going to write Avogadro's number, which you should have memorized by our formula units. So we're going to scroll back down to our problem, and we're going to write Avogadro's number right here, 6.02 times 10 to the 23 formula units. And we're going to write our molar mass beside grams. So it's kind of already nicely written out beside us. We only have one of each of these. So I get 22.99, 16.00, and 1.01, which is equal to 40 grams per mole, which will be written right here. Now, our next step is to multiply by a coefficient if they're different on both sides. But if I look, my compound on the left matches my compound on the right, so I don't have to do that. So all I need to do is cross multiply all of this by all of that. So in my calculator, remember, you're going to need to know how to put numbers that are in scientific notation in your calculator. So the way we would put this in our calculator is 40.00 times parenthesis 7.89, and then everyone has a button that either looks like EE or EXP. You push that instead of putting times 10. If you push the EE button, do not put times 10 in your calculator, and then we just put our exponent. So when I do that, 40.00 times parenthesis 7.89 EE 45, and I close my parenthesis and press enter, it gives me 3.16 times 10 to the 47 formula units of NaOH, grams of NaOH, over 6.02 times 10 to the 23 formula units of NaOH, equal to X grams of NaOH. We look at what cancels out. I have formula units of sodium hydroxide on the top and the bottom. And again, in our calculator, you need to make sure that the number on the top of your numerator goes in your calculator first. So we're going to take 3.16 times 10 to the 47, and we're going to divide it by 6.02 EE 23, close our parenthesis, press enter, and our final answer should be 5.24 times 10 to the 23 grams of sodium hydroxide. That's just a little review from last time. So now our last but not least, we have problem number 11. Now problem number 11 says how many grams are in 4.5 moles of sodium hydroxide? And we know that they're giving us that 4.5 moles sodium hydroxide. So we write down what's given, 4.5 moles sodium hydroxide. We set it equal to what they're looking for, which in this case they're looking for grams. Oops, wrong tool here. We want our highlighter. Grams. Okay, so we're going to set it equal to X grams of sodium hydroxide. Step 3 is to bring it on down. So I'm going to write moles sodium hydroxide on the bottom and grams of sodium hydroxide on the bottom. We always write the number 1 beside mole, and grams is our molar mass, which luckily we calculated that in problem number 10. So I can put my 40.00 grams right there. It's the same on both sides, so we do not need to multiply by a coefficient. So I'm just going to multiply this by this. So in our calculator, we have 40 times 4.5, which gives us 180 moles of NaOH, grams NaOH, over 1 mole of NaOH equal to X grams of NaOH. And when we solve completely, moles cancel out with moles, sodium hydroxide with sodium hydroxide, and 180 divided by 1 is just 180 grams of sodium hydroxide equal to X grams of sodium hydroxide. And I have figured out my final answer. Now, I have spent an hour helping you go through your study guide. Please take advantage of this opportunity. Go through it, enjoy it, learn from it. Come to me with questions tomorrow in class. And please, please, please study for your test at the end of this week.